Somewhere near the edge of the visible universe, there's a single object that outweighs every star in an entire galaxy put together. One object, one point in space. Light is the fastest thing there is. It gets from the sun to your eyes in 8 minutes. To cross this one object, light would need more than a week. It has a name. TON-618. And the more carefully astronomers look at it, the bigger the problem gets. Because by every rule we have about how the universe builds things, something this massive, this early, shouldn't be there. Over the next 20 minutes, I'll walk you through what you're actually looking at. How heavy it really is. Heavy enough that the number stops meaning anything, which is sort of the point. Why its size breaks rules the rest of the universe follows without complaint. What it would do to us if it ever came close. And near the end, one fact about this thing that turns the whole story around. The kind of fact that makes you stop and sit back. Because once you understand what TON-618 really is, you might start wondering whether you're sitting inside one right now. First, the basics. You'll need them. A black hole is a place where so much mass gets crammed into so little room that gravity closes over the top of it, like water over a dropped stone. Cross the edge, the event horizon, and there's no speed quick enough to climb back out, not even lights. Most black holes are small. A big star runs out of fuel, collapses and leaves behind something a few kilometers wide that still outweighs the sun. Our galaxy is full of them. Tens of millions drifting in the dark, almost impossible to spot. The big ones live at the centers of galaxies. Ours is called Sagittarius A star, the dark anchor sitting at the middle of the Milky Way. It weighs about 4 million suns. 4 million. Hold that number for a second, because here's where the video really starts. TON-618 may be 10,000 times heavier than that. Let that sit. One more thing, and then we go. A quasar is what a giant black hole looks like while it's still eating. Gas spiraling in, heating up. The whole region blazing brighter than the galaxy around it. From the far side of the universe, one feeding black hole can outshine 100 billion stars. TON-618 is the brightest one we've ever found. That's the first sign that something here is off. Here's the number. Everything else hangs on. The black hole inside TON-618 weighs somewhere around 40 billion times the mass of the sun. The older estimate ran higher, up near 66 billion. Either way, go back to Sagittarius A star, that 4 million sun giant anchoring our whole galaxy. TON-618 is close to 10,000 of those. Now the part I actually like, because it's the most human moment in the story. In 1957, an observatory in Mexico, Tenochtitlan, was running a routine survey of faint blue dots, the kind of housekeeping that fills catalogs nobody opens twice. One of those dots got written down as a dim blue star. Probably a white dwarf, they figured. Some little thing burning out quietly in our own neighborhood. It took years for anyone to look closer. Quasars hadn't even been discovered yet. That wouldn't happen until 1963. So there was no name for the thing they'd actually logged. That dim blue dot turned out to be a black hole 40 billion times the sun's mass. Its light ground down by 10 billion years of travel before it ever reached the telescope. One of the most extreme objects in the universe, sitting in a folder labeled Faint Blue Star. There's a fair question buried in all this. If a black hole gives off no light of its own, and this one sits 10 billion light years out, how does anyone put a number like 40 billion on it? The gas gives it away. Clouds of gas whip around the center of TON-618, and when you split its light into a spectrum, the speed of that gas leaves a mark. Faster gas smears the signal wider. Around TON-618, that smear is enormous, gas tearing around the middle at something like 10,000 kilometers a second, 3% of the speed of light. Only one thing pulls gas that hard. Measure the speed, measure how far out it's orbiting, and the mass of whatever sits in the center falls straight out of the arithmetic. Nobody has ever seen TON-618. We've only felt how hard it pulls. What we feel is 40 billion suns. Then there's the size. The event horizon would reach out past the orbit of Neptune, set TON-618 where the sun is, And the Earth is already inside it. So is Mars. So is Jupiter, Saturn, the whole arrangement gone, with the edge of the thing still stretching out past where Neptune used to be. Our sun would be a crumb going down. Gone the way a coin is gone the second it slips off your fingers over deep water. Quiet, complete, final. That's the headline. A black hole heavy enough to outweigh a galaxy's worth of stars and wide enough to eat a solar system. The size turns out to be the easy question. The hard one is how it got here. And that's where the numbers stop adding up. Black holes grow by eating. Gas falls in, the black hole gets heavier. Simple enough. There's a catch, and it's baked into physics. It's called the Eddington limit. When a black hole feeds too fast, the gas stacking up around it heats to millions of degrees and starts to blaze. That light pushes back. Push hard enough, and it shoves the next wave of gas away before it can fall in.